My introduction is Nikon Revelina Management Class 23A NPM 234110994. Here I will explain the material regarding empirical model form. Jogianto, 2008. Empirical model form can be collected based on data values or scale values. The data value is divided into two, namely metric data, which is data containing quantitative values, interval and ratio data types. Non-metric data, which is qualitative data which can take the form of an attribute, characteristic or category or dichotomy. Nominal and ordinal data types. Empirical form models. Empirical models can have more than one dependent variable. Included in empirical models that use one dependent variable are 1. Regression model equals y1, metric, equals x1 plus x2 plus xn, metric, non-metric. 2. Logit/Probit/Tobit regression model equals y1, non-metric, equals x1 plus x2 plus xn, metric, non-metric. 3. Discriminate analysis model equals y1, non-metric, equals x1 plus x2 plus xn, metric, non-metric. 4. ANOVA model equals y1, metric, equals x1 plus x2 plus xn, non-metric. 5. Conjoint analysis model equals y1, metric, non-metric, equals x1 plus x2 plus xn, non-metric. Empirical models that use more than one dependent variable are as follows. MANOVA model equals y1 plus y2 plus yn, metric, equals x1 plus x2 plus xn. Canonical correlation model equals y1 plus y2 plus yn, metric, non-metric, equals x1 plus. Simultaneous equations equals y1 equals x11 plus x12 plus x1n, y2 equals x21 plus x22 plus xnm. Yn, metric, equals xn1 plus xn2 plus xnm, metric, non-metric. Variables in empirical models. Models are symbolic forms of a theory. Models that show causal relationships between variables in the model are called causal models. A variable is a symbol that contains a value. Variables are grouped into dependent variable, VD. Independent variable, 6. Moderating variable, VMO. Mediating variable, VME, or mediating variable. Extraneous variables, VE, or extraneous variables. Analytical Techniques. Concoro, 2013, explains the analytical techniques used after determining the empirical model using multivariate analysis with the dependency method category, including multiple regression analysis, discriminate analysis, canonical correlation analysis, and MANOVA analysis. Regression analysis. Concoro, 2013, defines regression analysis as a statistical tool. Regression is useful in answering the following research questions. To what extent can the variation in changes in the dependent variable be explained by all the independent variables included in the model? Which of the independent variables affects the dependent variable? Can the inclusion of an additional independent variable improve the prediction of the dependent variable? Is the prediction of the dependent variable from a number of independent variables better than a combination of other independent variables? Will adding samples, observations, increase the predictive power of the model? OLS method, ordinary least squares. The essence of the OLS method is to estimate a regression line by minimizing the sum of the squared errors of each observation on that line. The main assumptions underlying the regression model using the OLS method are as follows. Linear regression model. X is assumed to be non-stochastic, meaning the value of X is assumed to be constant in repeated samples. The average error value is 0. Homoscedasticity, meaning that the error variance is the same for each period. There is no autocorrelation between errors. U and X are independent of each other. There is no perfect multicollinearity between independent variables. The number of observations, n, must be greater than the number of parameters estimated, the number of independent variables. There is variability in the X value, meaning that the X value must be different, not all the same. The regression model has been specified correctly. In other words, there is no specification bias, error, in the model used in the empirical analysis. According to the Gauss-Markov theorem, every OLS estimator must meet the blue criteria, namely, Gujarati, 2015. Best equals the best. Linear equals is a linear combination of sample data. Unbiased equals the average or expected value must be the same as the actual value. Efficient estimator equals has minimal variance among other unbiased estimates. Inference from regression results. Kung-Koro, 2013, stated that a statistical calculation is called statistically significant if the statistical test value is in the critical area, the area where Ho is rejected. On the other hand, it is said to be not significant if the statistical test value is in the area where Ho is accepted. In regression analysis there are three types of goodness of fit criteria, namely T-statistical test, F-statistical test, coefficient of determination. Maybe that all I can see. Thank you.